Hello, today we're going to look at solving some problems trying to combine some random variables. So first, this is just a generic problem without context, and then we'll build in context once we understand what we're doing better. Suppose we have two randomly distributed processes. One process, the mean is 50 with a standard deviation of 8, and the other one is normally distributed with a mean of 30 and a standard deviation of 6. So what is the probability that x plus y is greater than 95? So we want to write the probability that both these things occur and it takes more than 95 units to do it, whatever that unit is. So the first thing you have to do is think about what this random variable is. We need to find the mean of x plus y, and we need to find the standard deviation of x plus y. Well, the mean is easy. We just take 30 plus 50 to get 80. The standard deviation is less easy, still not super difficult, but the formula is we square each of the values and square root them, and we plug that into a calculator and we get a standard deviation of 10. Now that we have a mean and a standard deviation, now I can convert this to a z-score where I have 95 minus 80 over 10. That's the probability that my z-score is greater than 15 over 10, which is 1.5. Now we use whatever device we want to find the normal CDF or the tables, going from 1.5 to infinity, and we get a value of 0.0668. So about 6.5, 7% of the time, it takes more than 95 minutes or whatever to complete those tasks. So in this one, it says, what is the probability that x is greater than y? So if I want to find the probability that x is greater than y, what I have to do is struggle for a little bit because there's not a number over here. Well, let's think about how we can do this algebraically. Well, we can subtract y from both sides, and x minus y has to be greater than 0. So now that we have this, we could move forward if I knew the mean of x minus y and the standard deviation of x minus y. The mean of x minus y, we take the mean of x minus the mean of y. That's 20. The standard deviation of x minus y is going to be the same as standard deviation of x plus y. This squared plus this squared equals c squared. So that is also going to be 10. So now if I can convert this to a z-score, and I'm going to take my x value 0 minus 20 over 10. So that's going to be the probability my z-score is greater than -2. So I just plug this in my trusty calculator. I'm going to go from -2 to infinity, and the probability that's greater is 0.977. So about 97.7% of the time, x is going to be greater than y. All right, so now that we understand that, now we can build some context. Suppose that the time it takes to assemble a computer is normally distributed with a mean of 6 and a standard deviation of 1.2, and the time required to box it and get it in the truck is normally distributed with a mean of 2 and a standard deviation of 5. Assume that each of these are independent of each other. Knowing that, we want to find the probability that the entire process takes more than 10 hours. So probability that that entire process that's doing x plus y is greater than 10 hours. We can do this as long as we have the mean of x plus y and the standard deviation of x plus y. So the mean is always pretty easy. We add the two values, we have a mean of 8. The standard deviation is less easy. We have these two values, 1.2 and 0.5, and we have to use that standard deviation, our Pythagorean theorem of statistics, 1.2 squared plus 0.5 squared, and then we square root it. Now if we do that, we have 1.2 squared plus 0.5 squared, square root that value, you get 1.3. So this equals 1.3. Now that I have both of these, I can come back and I can say this is the probability that my z-score is greater than 8 or 10 minus my mean over my standard deviation. So that's the probability my z-score is greater than 2 divided by 1.3, 1.538. And now I just have to take a normal CDF from that value to a big number, and I get about 6% of the time that happens. So 0.062. All right. Now here it says, what is the probability it takes less than 15 hours to assemble 3 computers? Now, one thing that's confusing about this is not 3x. Since you're doing something 3 times, this is x plus x plus x. So we're assembling 3 computers. Now, if we're doing one thing and multiplying the price times 3, we could do 3x. But this is not that. So, oh, I forgot something here. It's less than 15 hours. All right. So that's our goal. So in order to solve anything like that, now we got to find the mean of x plus x plus x and the standard deviation of x plus x plus x. So the mean of x plus x plus x was at 6. 6 plus 6 plus 6. That gets us to 18. And the standard deviation, now we're doing Pythagorean theorem in 3 dimensions. It's 1.2 squared plus 1.2 squared plus 1.2 squared, and square root that. And so I'll take out my calculator. I got 4.32 and I square root it. I'll write this on the other side, 2.078. Would have been nice if your teacher gave you more room to write here. Oh well. So now if we take this, I'm going to find the probability that my z-score is less than my x value minus my mean over my standard deviation of 2.078. And that's going to be -3 over that answer. So that's going to be the probability my z-score is less than -1.44, which is normal CDF from -infinity all the way up to -1.44. And I get about 7% of the time, 0.075-ish. All right, now it says, what is the probability the crew could assemble a computer quicker than it could box and load 2 computers? So probability that I can do a computer quicker, so that's less time than 2 computers. So it's taking less time for the computer to assemble the computer than box and load 2 of them. Now we have to do a little algebra. X minus y is less than 0 because we want a number over here. Now that we have this value, we need to find the mean of x minus y, and we need to find the standard deviation of x minus y. All right, the mean should be easy as long as we remember the values. 6 minus 2 minus 2, that's 6 minus 4, or 2. The standard deviation is going to be 1.2 squared plus 0.5 squared plus 0.5 squared, and then we square root that. So 1.2 squared plus 0.5 squared plus 0.5 squared, then we square root that value, and we got a standard deviation of 1.39. So now I can convert this to a z-score by taking 0 minus the mean over my standard deviation, 1.39. And so -2 over that answer gets us to z is less than -1.436. And now I do my normal CDF from a negative number all the way up to that. And I get 0.075 again, because you can see those are very close. All right, hopefully you're getting the hang of that. Now try the rest of the problems as on your own because they're really just the same thing. I'll just keep repeating. All right, good luck.